All right, the first question asks what the concentration will be in milligrams per milliliter if we add 15 mils of water to 3,000 milligrams drug powder to give a solution volume of 20 mils. So this is actually pretty straightforward. We know what the total drug mass is going to be, 3,000 milligrams, same as 3 grams. And so we just really have to decide which volume to put on the bottom. Do we put the solution volume of 20 mils, or do we put the solvent volume of 15 mils on the bottom? And that's really the quiz here. You should know that a solution concentration, drug strength, is going to be the total amount of drug divided by the total volume of the solution. So it should be 20 mils on the bottom. And so we'll just divide those to get 150 milligrams per milliliter. Okay, next question. Adding 155 milliliters water to 4 grams drug powder gives a solution concentration of 25 milligrams per milliliter. What's the drug powder volume? So this one's a little bit tricky because we're not given the solution volume outright. We have the volume of the solvent. So we have the volume of the solvent, and we know that the volume of the solution minus the volume of the solvent would equal the volume of the drug. So we did that before. And so we have the 155 mils of solvent. So can we use the other information to find the mils of solution? And we can, because this concentration right here has a volume on the bottom that's mils of solution. And so we can set up a proportion that says we have 4,000 milligrams drug powder, and we want to know how many mils of solution is that in? What's the total volume of solution? And we know that there are 25 milligrams of drug for every milliliter of solution, and so we have a proportion. So 4,000 divided by 25, and that should give 160 mils of solution. So there's our solution volume. 160 mils minus 155, that gives us our drug volume of 5 milliliters. Okay, the last one, maybe the least straightforward of all. We dissolve a drug powder in 43 mils of water, and we'll get a 50 ml solution with a concentration of 125 milligrams per teaspoon. So how many mils of water should be added to get 250 milligrams per teaspoon instead? And so we actually have to prepare this powder so that it gives a different concentration than you would normally. And so let's think about this kind of master equation we have, where we put the mass of drug over the solution volume, which is volume of solvent plus volume of drug. And that's going to equal the concentration, which is 250 milligrams per 5 mils. And we can divide that through to just get 50 milligrams per mil. All right, so what information do we have and what do we need? It's asking how many mils of water should be added. So the volume of solvent is our X. That's what we're looking for. So somewhere in the problem, or using what we've been given, we should be able to find the volume of drug. We should be able to find the mass of drug. Okay, so we get a 50 ml solution with a drug concentration of this from our powder. We're using the same powder, so we can set up a proportion that is 125 milligrams of drug for 5 mils of solution, and then ask how many milligrams of drug is there in the entire 50 ml solution. So we end up with 1,250 milligrams in the whole thing. So that's our massive drug, 1,250 milligrams. And actually the volume of drug is pretty straightforward, because we can take the mils of solution, subtract the mils of water, and that gives us 7 milliliters of drug. So the 7 mils goes in here. And so now we have all the things that we need to solve for volume of solvent. And that should be a V, just to make that clear. The whole thing's volume of solution, and that's volume of solvent plus volume of drug. Okay, so this equals 1250 over x plus 7. We can bring the whole x plus 7 up, bring the 50 down, just trade places with those two, and that gives us x plus 7 equals 1250 divided by 50. So x equals 25 minus 7 equals 18. And so that will be our volume of solvent. So 18 milliliters water.